Hi guys, today we're gonna go ahead and do some fun word problems. Yay! They're so exciting that I wouldn't be surprised if they were on your test. So let's do this. So we have some applications of linear functions, which is just code for like, let's apply our skills in terms of this material. So the prompt reads, the following linear equation describes the relationship between the number of years x past 2000 and the average cost of apples y in dollars per pound. Okay, that's like a lot of information. Let's go ahead and read it like 10 more times. So we have some equation. That's nice. It will be nice if we have a clear idea of what the x and y variables represent. If we don't, there's really no need to move forward. Okay, so we have some equation. Okay, that's nice. What is so special about it? So the following linear equation describes the relationship between, so it's going to talk about the number of years x past 2000. Okay, so it's the relationship between the number of years x past 2000. Okay, so x represents time, okay, or the years, okay, but to be more specific, we want recency. Like, I can care less what happened like 200 years ago. Okay, so x represents the years past 2000. So let me go ahead and speak to myself. So x represents the number of years. I'm just gonna put the pound sign because I'm not defining the variable. We didn't introduce it, so we're not defining it. Okay, so I'm just summarizing it. So x represents the number of years past 2000. Yes, I can read it, but there's something about us writing that it clicks. So when I look at my notes, I'm like, okay, what does x represent? Oh, my notes. Oh, it's the number of years, past 2000. Cool. Okay, and the average cost of apples y in dollars per pound. Okay, so we know what x represents. It's the number of years past 2000. What does y represent? It represents the average cost of apples, and those are the units. So y represents the average cost of apples, and the units are in dollars per pound. Okay, so dollars per pound. So I put the abbreviation. Okay, so again, we need to have a clear idea of what these variables represent. If not, no. Okay, so cool. So y represents the average cost. So I guess to find the average cost of apples at any given time, we're gonna take 0.04, multiply it by x, multiply it by the years past 2000, and then add to it 0.82, whatever that is. That will give us so many dollars per pound, the average cost of apples. Okay, so the question, we have two questions, a two-part question. A, according to this equation, what was the cost of apples in 2003? And then typically when we have a word problem, we write our answer in a complete sentence, but we're given the green light not to write it in a sentence, so I'm gonna take it. Okay, A, what was the cost of apples in 2003? Okay, now I know you're in a genius. Okay, so you can go straight to attack mode, but I'm not, so I need to break it down. So I'm gonna write down what I am asked to find, and then I'm gonna write down what's given. Okay, what was the cost? So this is my thinking. Cost, no idea. So cost, and then I'm like, okay, cost, is that the x or is that the y? Cost, well, x represents the years past 2000, and y was the average cost. So the x is associated with the years past 2000, and y is associated with the cost. Okay, so what was the cost? So this is me brainstorming. Cost, which is y, equals, I have no idea. Okay, there's something about me writing down what I'm asked to find in this format that it kind of guides me, like, find this. Okay, what was the cost of apples in 2003? So what was the cost in the year 2003? Okay, so the time is associated with x. So my train of thought wants to say, oh look, in the year 2003, quick, x equals 2003. But again, we want recency. Even 2000 is a little outdated, but it is what it is. So x represents 2000. we want to know what would be the corresponding x value for the year 2003. So in this case, I know you know the drill, but I want to vent out a thought process. Okay, since we're starting to count the years, since 2000, or the years past I'll say that again. Since we're starting to count the years past 2000, I want to know if it's 2003, how many years has passed since, and then that difference gives us 3. Sorry, okay, I shouldn't drink so much coffee, okay? So if the year is 2003, that means that 3 years has passed since the year 2000. So the moral of the story, all wording aside, what this breaks down to is this: find y when x equals 3. Oh, I could do that. I could find y when x equals 3. We have a neat equation that allows us to find y, or the cost at any given time. So we're going to start out with writing out the equation. We have y equals 0.04x plus 0.82. And what are we going to do? Oh, sorry, thinking it. We're going to find y when x equals 3. So we're going to plug in the 3 for x and then solve for y. So we have 0.04 times our x value of 3. And we didn't plug in a 3 because we felt like it came from the problem, you know. So that will give us 0.4 cents. So 0.04 times 3 will give us 0.12. And if my eyes don't fail me, 0.12 times 0.82 will give us 0.94. Okay, so the question says, what was the cost? Okay, so in this case, that was the cost. Y represents the average cost of apples, and the units are in dollars per pound. So let me just tag along the unit. Although we don't have to write our answer in a complete sentence, please don't submit the variable in your answer. Okay, so let's just go ahead, write it. So it's going to be 94 cents a pound. Okay, so we're going to put the dollar sign. It's 94 cents a pound. In 2003, the average cost of apples was about 94 cents per pound. Oh yeah, that's no, yeah, we pay way more than that. Okay, for the grand finale, because it's a two-part question, remember, pause and rewind as many times as needed. Okay, so part B, when was the average cost of apples about $1.06 per pound? And then remember, same disclaimer, you don't have to write your answer in a sentence. So when, I'm looking for the time or the year, so I'm gonna say year equals question mark. So year, which is associated with x, equals question mark. When was the average cost of apples about $1.06 per pound? So the cost equals $1.06 a pound. Cost is associated with y. Okay, so all wording aside, what this problem boils down to is this: find x when y equals $1.06, okay, well, per pound. Okay, so you answer however you like. I'm very mechanical, so if there's an equation, I'm gonna attack it. Okay, so start off with the equation, which is y equals 0.04x plus 0.82. Y equals 0.0x plus 0.82. Fantastic. Plug in what we can and then solve for what we need to. So we're going to substitute 1.06 for y, and then we're going to solve for x. So bring down the rest of the equation. Let's do this. So to isolate the variable term, let's subtract 82 cents from both sides. And then when we punch it in, the left side difference of $1.06 and 82 cents should give us 24 cents. To finish it off, to isolate the variable term, let's go ahead and divide both sides by 0.04. And when we keep our cool, quotient of those two numbers on the left should give us 6. So to answer the question, when was the average cost of apples about $1.06 per pound? We're not going to say, oh, in the year 6. Oh, the apples don't even cost that right now. Okay, so in this case, x represents years past 2000. Okay, so if x equals 6, then 2 years past 2000, sorry, if x equals 6, then 6 years past 2000 will give us 2006. If you're an overachiever, go ahead, write your answer in a sentence, but I'm going to take the green light. Fantastic. One word problem down, one more to go. Bear with me. All right, guys, second word problem, and we're good to go. Okay, so it reads, find the linear equation that models the following information. Okay, difference between this problem and the problem before. The problem that we just knocked out, oh, I put it away. The problem that we knocked out, they gave us the equation to begin with, and then we had to answer a bunch of questions. This time around, they want us to find the equation itself and then answer a bunch of questions. So let's break it down. So it says a circuit board company has initial cost of $1,000 per week, and it costs them 50 cents per board. Let Y represent the cost to run the company each week, and X to represent the number of boards made each week. Okay, that's like a lot of neat information. Okay, so they want us to answer these three problems. I mean, I guess I'm supposed to read them now, but for me, I'm very adamant about making sure I understand what the variables represent. We do not have to define the variable. They told us let Y represent this and X represent that. Okay, so they introduced it and they defined it. But I said it before, there's something about us writing it together that kind of like it's ingrained into my head that like I understand it. I don't know if that made sense, but I understood myself. Okay, so we have the variable Y and we have the variable X. So let me start off with X. What does X represent? And X to represent the number of boards made each week. Let me write that down. Okay, so I'm not gonna use a let statement. Okay, so I'll just put a semicolon. I mean, that's a colon, I think. Okay, that's the ugliest colon ever. All right, so what does X represent? The number of boards made each week. Okay, I'm gonna underline that. Okay, the number of boards made each week. Fantastic. Okay, one variable down, one more to go. Y, what does that represent? Let Y represent the cost to run the company each week. Okay, the cost to run the company each week. Okay, so X, the number of boards made each week. The Y, the cost to run the company each week. Okay, cool. So part A, problem A. Find the linear equation that models the cost for the circuit board company. Okay, you can answer however you want. Okay, this is how we're gonna do it. Find the linear equation that models the cost for the circuit board company. Okay, so let's see, how do we calculate the cost? A circuit board company has initial cost of $1,000 per week. Okay, they have initial cost of $1,000 per week, so that's like their startup weekly cost. So even if they don't make anything, they still gotta dish out a grant. Okay, and it costs them 50 cents per board. Okay, so aside from the initial cost, it costs them 50 cents per board. So for every circuit board that they make, the cost is gonna increase by 50 cents. Okay, so let me write down in words. So how do we calculate the weekly cost? Okay, why do I say weekly cost versus like monthly cost or daily cost? That's because of the way it's phrased. What do I know about this company? They have initial cost of $1,000 per week. Y represents the cost to run the company each week. So there's the magic word, week, and X to represent the number of boards made each week. Okay, so we take this on a week by week basis. Okay, so our model is going to talk about, you know, the weekly cost. So how do we calculate the weekly cost? Well, we know that they have an initial cost of $1,000 per week. So we have the initial cost, which is $1,000. Okay, I'm not gonna put the units here, so let me just put it right there. Okay, so the units associated with the 1,000 is dollars. So guess what? Y, which represents the cost to run the company each week, will have to be in terms of dollars. Fantastic. So what's the weekly cost? So it's the initial cost of 1,000 plus the cost of making all those circuit boards. Okay, so I'm going to say plus the cost of making, I'm going to say X circuit boards. X circuit boards. Now, we know that it costs them 50 cents to make each circuit board. So what would be an expression to make X circuit boards? So it's like if we only made a circuit board, it'll be 50 cents times 1. If we made 2 circuit boards, 50 cents times 2. 3 circuit boards, 50 cents times 3, and you get the drill. Okay, so an expression that represents the cost of making X circuit boards will be 50 cents, times X circuit boards. But we're gonna have to write 50 cents as a fraction of $1 because of the units. Okay, so we're gonna have to write it as 0.50. Okay, so it's gonna be 0.50 times the number of circuit boards. Okay, so how do we calculate the weekly cost? What does Y represent? The cost to run the company each week. Okay, so the weekly cost, namely Y, how do we calculate? We take the initial cost of $1,000 and then add to it the cost of making X circuit boards. This is like too spaced out for me, so let me just write it closer to each other. So we have 1,000 plus 0.50x. If you want to omit the 0 at the far right, that's fine. If you want to omit the 0 for the whole number part, that's fine. I like this equation because it's written how I think, what I would normally think. Sorry for the redundancy. I'm like, okay, how do we calculate the weekly cost? Oh, the initial cost plus the cost of however many boards we make. But of course, when we look at the back of the book cannot read our mind because they choose to write it in slope-intercept form. Okay, I don't really care how you write it as long as the 1,000 is positive and the X term is also positive. So I just want to throw it out. Anytime that the answer is not written how the book is, I need to talk to you about it. Okay, so we have 2 more problems and then we're good for this entire unit. Part B, write a complete sentence explaining the meaning of the Y-intercept in this application. Okay, I'm going to write a sentence. We all speak a little bit differently, so your sentence may be a little bit different than mine, but this is how I'm going to write it. Okay, give me a sec. Okay. So let me go ahead, write out the equation, and this time around I'm going to write it in slope-intercept form because we have it anyways. I cannot speak, think, and write at the same time, so let me go ahead and write it. Okay, so question B, write a complete sentence explaining the meaning of the Y-intercept in this application. So if I have to explain what the Y-intercept is, then I need to have a clear idea of what is the Y-intercept. Bear in mind that this is in slope-intercept form. Okay, Y equals mx plus b. Okay, so in this case, the Y-intercept is 1,000. Okay, Y-intercept equals 1,000. Okay, to facilitate the explanation of the Y-intercept, I will choose to write the Y-intercept as an ordered pair, x comma y. Okay, if you feel comfortable writing it right now, or if you want to like graph it so it's a little bit easier to digest, and that's fine too. Okay, let's go ahead and do our XY plane. X represents, oh, let me zoom out. Okay, what does X represent? X represents the number of boards made each week. Okay, so I'm gonna say that we have the number of boards. Y represents what? The cost to run the company each week. Okay, so let me just put cost, and the units are in terms of dollars. Okay, so the Y-intercept is at 1,000. So I'm just gonna go ahead, graph it, and I'm gonna say that this is 1,000. Okay, if the Y-intercept, yeah, that's terrible, sorry. If the Y-intercept is 1,000, which that doesn't even look like 1,000, sorry, this is a point, and that's the number 1,000. I've made it worse, sorry. Okay, If the y-intercept is at 1000, so that means that if we were to graph this, then the line will intersect the y-axis at 1000. As an ordered pair, the value of x at this point is 0. Ooh, so let's go ahead and write it as an ordered pair. Okay. Now I'm gonna talk to you, and then you digest it however you can. Okay. So what does x represent? So x represents the number of boards made each week. Okay, so let me just put number of boards. Okay, what does y represent? The cost to run the company each week. So I'm just gonna say weekly cost. Okay, to facilitate what the y-intercept represents, I'm just gonna say this: when x equals this, y equals that. When x equals 0, or when we don't make any circuit boards, y equals 1000. When x equals 0, or when we don't make any circuit boards, the weekly cost is $1,000. So you can just write it like that. You know what? How is it phrased? Write a complete sentence explaining the meaning of the y-intercept in this application. So we'll just say it like that. If no circuit boards are made, the weekly cost is $1,000. Full credit for that. Okay, but I'm gonna write that a little bit more concise. Okay, so even if we don't make anything, we still gotta dish out this. So I'm just gonna say that the y-intercept tells us that the initial cost to run the company is $1,000 per week. Okay, the initial cost to run the company is $1,000 per week. Oh my goodness, my writing is getting worse. Oh no, sorry about that. Okay, so the y-intercept tells us that the initial weekly cost to run the company is $1,000. Phrase it however you like. Okay, I'm just gonna look for the number 1000 in there. We all speak a little bit different, so of course our answers are gonna be a little bit different. Okay, let's go ahead and move on to number C. Okay, where am I? C. Okay, write a complete sentence explaining the meaning of the slope in this application. Okay, so in this case, where am I? Okay, we want to explain the meaning of the slope. In order for us to explain the meaning of the slope for this problem, I need to have a clear idea of what the slope is. Okay, so let me go ahead and write down our model, okay, of the equation we found. So we have y equals 0.50x plus 1000. Okay, so let's remind ourselves, y represents the cost to run the company each week. Okay, this is in slope intercept form, so in this case our slope is 0.50. For me, I say for me, in order to have a fair chance to explain the meaning of the slope, I'm gonna write down the units. Okay, so it's 0.50, and the units will be the units on y over x. Okay, what do we say? Slope ratio of rise to run. Okay, difference of y's or difference of x's. So be 0.50, the units on y. Y represents the cost, and the units on cost is dollars. So it's going to be $0.50 per whatever the unit on x is. X represents the number of boards made, so in this case it's going to be $0.50 per board. Okay, we don't speak like that, so we're gonna put the dollar sign before. Okay, so I'm gonna try to write down how I brainstorm. So whenever I have to explain the meaning of the slope, this is like my first question: is the slope positive? Is the slope negative? It didn't sound like a question, so I want to know, is the slope positive or is the slope negative? So in this case, our slope is positive. Okay, If we were to graph our equation, if the slope is positive, then the line is expected to go up, right? So on the contrary, if the slope was negative, then the line was expected to go down, but that's not our case. Okay. Since the slope is positive, then the line is expected to go up. And if the line points up, well, let me write that down. Okay, slope is positive, so graph points up. Okay. Since our slope is positive, then the graph is expected to point up. And if the graph points up, then guess what is increasing? The value of y. So right here we have y equals 1,000. Right here we have y equals, I don't know, something more than 1,000, something more, something more. Okay. So since the graph points up, then that means that the value of y is increasing. So the graph points up. That means that the value of whatever y represents is increasing. Now, what will be the opposite? If the slope is negative, then the graph will be pointing down. And if the graph is pointing down, then the value of y is decreasing. So I share that because we don't have another word problem. Okay. So what does the slope tells us? Okay. So the slope tells us that the value of y is increasing. Well, that's nice. But let's remind the world what y represents. So y represents the cost or the weekly cost. Okay. Since our slope is positive, and that means that the graph points up. And if the graph points up, then the value of y is increasing. If the value of y is increasing, then I guess the cost, or I can say weekly cost, is increasing. Okay. Why do I say this over and over? Because I'm trying to scaffold, you know. Okay. So slope is positive, means that the graph points up. If the graph is pointing up, something is increasing, the value of y. What does y represent? The cost or weekly cost. So the slope tells us that the weekly cost is increasing. But it's increasing by what? It's increasing by whatever the slope is. Okay, it's increasing by 50 cents per board, and you can phrase it just like that. Okay. What's so special about the slope? The slope tells us that the weekly cost to run the company is increasing by 50 cents per board. It's increasing by 50 cents for every circuit board made. Okay, dish it out however you like. Let me go ahead and write it. Okay, I'm gonna start it like backwards. I'm gonna say for every circuit board that is made, the weekly cost is increasing by 50 cents. But phrase it however you like. Okay, for each circuit board that is made, the weekly cost to run the company is, yeah, this is not aesthetically pleasing, sorry, is increasing by 50 cents. All right, cool. Remind me just to continue writing on a separate sheet of paper. So yeah, again, when it comes to writing your answer in the sentence, we don't all speak the same. Okay, so I'm not expecting for us to write the sentence in the same exact format. Write it however you want. I'm just looking for words like increasing. I'm hoping that there's a 50 cents in there. Okay, so again, if I just read this from left to right, I will write this sentence. Okay, the slope tells us that the weekly cost is increasing by 50 cents per board, per circuit board, and then we're good. Okay, my friends, so I said we were gonna do 2 word problems. That was the second one, so we're out. Gracias.